So you can see. So here I want to explain the basic explanation. I mean, I'll take a direct formulas and explanation within 30 minutes. I'll conclude. Then example problems, applications, and gravitational field I'll give in another topic. So coming into gravitational field. So everybody know about the field. What is field? Field means it is the region. So where the region, the where the other mass experiences force. So it is called field. That field can be magnetic field, gravitational field, electric field, whatever it is. The field is nothing but the region where other charged particle, other magnet are mass. So here I want to give one clarity. So in electric field maximum I completed this. So again magnetic field also I will explain in some cases. So all common gravitation field, gravitation force, electric field, electrostatic force, magnetic field, magnetic force. So the concept is same, but consideration and process is somewhat different. Whereas gravitational field, gravitational force, electric force, electric potential, gravitational potential, similar there is no doubt. So here for gravitational force and field for gravity, the source is mass. The source is mass. So for as this is for gravitational field. Field or force. So whereas electric field, if you coming to electric field, the source is charge. The source is charge. So coming into magnetic field, the source is magnet, means natural magnet, or current element, ideal element, moving charge. So these are the sources for fields. It means formulas are same, but there in the mass gravitational field we'll discuss about the mass. Electric field behavior of charge, how it will be plus to minus. If plus means how field lines are, minus means how field lines are. Similarly, coming into magnet south pole, poles, polarity, pole strength. So that we'll discuss. So that is means here comparison I'm trying to give because already electric field in different cases I have given some videos. So there you can check. So now whereas coming into this, for example, here this is so maximum cases gravitational field will find out for our Earth only. So this is our Earth of mass m or any particle of mass m. So here one particle of unit mass, some mass is there. So it experiences the force. So every particle wherever except infinite there is a force. The force already we know inverse with the distance. So it will be decreases by increasing the distance. So after some time this force can be this effect of this force, the gravitational field will be zero or less, very less. So up to this region around this mass. So this region is called, so in this region from this point to so this point, this region is called field. So this R can be written as R plus H also. Therefore, field is nothing but the force on mass. Force on mass. Field is a vector. Therefore, force is equal to m into E bar. That means force parallel to field. The force on the mass m is parallel to field. Our field is parallel to force. That means line joining two masses. Already we studied this in force concept, right? Two masses. The field direction also same like that. So from this formula, I can write field E is equal to the magnitude of field E is equal to GMM by R square into M, force by M. MM get cancelled. So that equal to GM by R square. So this is, it is very clear that the field, the strength of the field depends on mass of source body, and depends on the distance. That means position of the body. It is independent on mass of particle. So in some special cases, the gravitational field I can tell means from the formula. From the formula I can tell it will be acceleration. Field will be acceleration, that is equal to acceleration due to gravity. So G. So why that's in some cases only means, so if you take the acceleration directly in inversely proportional to mass of the body. So acceleration of the mass is inversely proportional to acceleration is inversely proportional to its mass. So in Newton laws we studied this, right? So SI unit of field is equal to force by M, that is equal to Newton by kg. The force per unit mass also you can consider. So dimension formula ml t power minus 2 by M. So that equal to L t power minus 2. From the dimension formula also we can say the field is acceleration. Acceleration dimension formula and field dimension formula are same. So whereas the field is vector, the field is a vector. That means compulsory follows the vector law of addition. So then only that quantity is said to be vector. Only direction magnitude is there means this is not a vector like temperature, current, pressure. They have direction and magnitude, but they are not vectors because they are not follow the vector law of addition. Means sum is not equal to the vector addition. So that you know already in vectors. So now here I will explain the field due to the different bodies. So first of all, we'll go with the field of ring. The field due to ring. Let's consider so ring of mass m. From the ring in the distance x, there is one unit mass point P is there unit mass. So hereafter we have to consider small element, and the small element distance is the root over r square plus x square. So this is r. So the explanation of this one, how this and all is coming, I have given in electric field. The same process will follow here. So that means I am indirectly telling that you can verify that electric field explanation. So then you will get the comparison easily to remember the formulas also. So now if you see, so as we discussed, the field or force is acting along the line joining like this. So now the components of fields are like this. If due to the symmetric mass, so here forces, then the force along this direction will be added and force along vertical cancels. So therefore, so dE due to small element, dE cos theta is E. Integral dE cos theta is equal to E. And here this angle consider theta. So now dm mass, now E is equal to So at this point, unit mass d to the small element that equal to g into dm by r square means r square plus x square. So actually root whole square means this is only will come. So this is dE. Then dE cos theta e plus g dm by r square plus x square into cos theta. So now integral of dE from, so now theta is, so now this is theta, where it will be 90 minus theta. And here you have to find out the angle between the this dm mass and the distance here. So it will become theta. So then this is also theta will come. So now after solving the field into ring, so dm value substitute and integral from theta to 0 to 2 pi. So the finally the answer for ring. So okay, I will explain this one. Remaining and all I will go the normally. So here dm is equal to, so ring it is right, lambda into r d theta. So lambda into dl, that dl is equal to r d theta will come here. So this d theta is changing from 0 to 2 pi, right? So now we'll substitute. So that is g into the lambda r d theta cos theta by r square plus x square. So now the lambda value you can substitute again. That is mass by length of this ring 2 pi r again. So now we'll get the field due to the ring is. So here we have to integrate the d theta. So you can ask here if I am substituting while integrating theta, cos theta is there, na cos theta we can integrate. So here this theta and this theta is different here. See, so we can go, this is as phi you consider d phi. So r into d phi will come. This is also d phi. So d phi we have to integrate. Therefore substitute the cos theta value from the diagram. So g lambda into cos theta is equal to adjacent side by hypotenuse, that is equal to r square plus x square whole power 3 by 2 into here r is there again, r into d phi. This is dm value. Here substitute and integrate. So that is equal to 0 to 2 pi g lambda into r square plus x square whole power 3 by 2. So cos theta is equal to here. So dm I substituted in the dm value. I substituted and I got this one. X into r into integral. So 0 to 2 pi d phi. So that equal to g into 2 pi r by here x r square plus x square whole power 3 by 2. So now this is equal to convert into m. So whereas lambda is equal to m by 2 pi r. So now that is equal to 2m into x by r square plus x square whole power 3 by 2. So therefore the finally the field d to the ring, magnetic field d to ring is equal to gm into x by r square plus x square whole power 3 by 2. The same formula we use for disk also. Means disk is combination of small rings, right? So the small element here dm, in the place of m we'll write dm, that is d to small ring, that will be integrated to 0 to r, will get the disk also. So these explanations under in electric field same I have given there, you can check. So hereafter I'll write only formulas, only direct formulas and explanation I will write. So now see, so dE by dx is equal to 0 after derivating. So we'll get x is equal to plus or minus r by root 2. This means the field d to ring, the field d to ring is maximum at dE by 0, dE by dx is equal to your appearance maximum field is representing the field, right? Right. So here at these points, field is maximum. So this is x values, and on y-axis field value. So now x is equal to minus r by root 2, here plus r by root 2. So field is maximum. So the maximum field is how much? So this x equal to plus or minus r by 2, you can substitute here. So E maximum is equal to gm into r by root 2 into, so here 3 r square by 2 will come, whole power 3 by 2. So now this will be simplified, that equal to this 2 cube root means 8 root 8 will come here, that equal to 2 I can write 2 gm by 3 cube whole power root 2, so that equal 3 root 2, 3 root 3, 3 root 3 into r square, the square and the root 2 get cancelled, r cube above r is there, therefore r square. So the maximum field of the ring, the E maxima is equal to at x equal to plus or minus r by 2, which is equal to this value, E maximum. And at the center, so at x equal to 0, at x equal to 0, which represents center. So at x equal to 0 center, the field is also 0, D2 ring. So this is about ring. So now on the surface, that equals gm by r square, gm by 2 root 2 into r square. So x equal to r is up to, so x equal to r means here 2 r square will come. So that equal to it is 2 root 2 will come, 2 power 2 cube means 8 root 8, that equal to 2 root 2 into r square r cube, here r x equal to r sub 2 is r square. So that equal to gm by at on surface at x equal to r. So then E is equal to at x equal to r, E is equal to gm by 2 root 2 into r square. So this represents this one and this one represents parabolic equation. So y equal to some 2a into x power x square, or x is equal x square is equal to, so minus power parabola. So like this. So now field due to disk, field due to disk. So disk means you people know very clear, that is, so mass is distributed the overall, right? So from this point, somewhere there is a one point here I want to find out. Just in seconds. So for that I will consider small ring. So the small ring of mass dm. So this mass is equal to dm. So now at this point due to this dm, we know already due to this ring of dm mass, that equal to gm into gm dash into x by. So this is a square plus x square whole power 3 by 2, because the radius of this one is equal to a. So now the integration values are a is trans to 0 to r, and here dm is equal to, so sigma into dA. So that is equal to, so m by pi a square into 4 pi a dA, 2 pi a dA, right? So this is dm mass that you will substitute here, and we are getting the final formula. The E is equal to E d2 ring disk is equal to E of the disk is equal to 2 gm by r square into 1 minus x by root over r square plus x square. This is field due to disk. So suppose this R value is infinite. The R value is infinite. That means infinite seat of mass m. So now field is equal to field E to that shape is equal to 2 times of Gm by R square. So that field is equal to 2 times of our earth field. That means already our earth has a radius R, it is very, very big. So if more times bigger than that, how the gravity is 2 times. So the gravity of sun even 2.4 times, 2.7 times of earth gravity. So that we know already. So sun compared to earth, sun, the radius is very big. Our mass is very big. Now, so due to solid sphere, the field due to solid sphere, gravitational field due to solid sphere. So now let's consider the solid sphere of mass m, and in this solid sphere, so at point P, point A, and point B, so masses are placed like that. Consider. So I'm going to field on these masses. That means one is R is greater than R, one point, P point is R is greater than R, and point A is R is equal to R means surface, and B point is R less than R. So as in the force we discussed similarly, the same way, the field outside is equal to Gm by R square. The field in is equal to Gm by R cube into small r. Field on surface Gm by R square, which is equal to G. So this is field on surface means R is equal to R. Field inside means R less than R. So that is due to effective mass m dash. Okay, that m dash is equal to capital M into small r cube by capital R cube. In self energy, this is very important. There I'll explain again. So for R greater than R. So this is field means force by M we can substitute directly. Already explained force values, force formulas. So you can check. So now the graph for this one. So if you see formulas, so inside is linearly proportional to R. So increases up to one value. So thereafter it will be decreases exponentially, means parabolical. So this is R, and here it is field. So this is the maximum field that equal to Gm by R square. So whereas field E inside the solid sphere proportional to R, outside is inversely proportional to 1 by R square. So here one example I will give. So in the place of R value, they will give the distance. R, the distance is x means centimeters in terms of centimeters or meters. They will give centimeters only. They will give maximum, and mass they will give mass of the solid sphere and density of the solid sphere or radius. They will give means density and radius means value. So that case and all you know, right? So in electric field there you studied. Otherwise in applications I will try to explain. So now coming into hollow sphere. Hollow sphere or cell, spherical cell. Spherical cell. In problem they will mention some of the problems they will mention instead of hollow sphere, spherical cell they will mention. So there also this one. So now let's consider hollow cell. So inside there is no mass, right? The total mass is concentrated at M here center, but here no mass. Okay, here mass is not there. This mass is concentrated for point P here. So therefore, E out is equal to G into M by R square. Because hollow sphere and solid sphere mass is same, consider here. Mass is, here mass I am writing, there is a mass of this body, right? So this is for R greater than R value, means outside point. So E inside is equal to 0. That means the effect of field always away from the mass. So that will be one good example we can tell. So here one man is there standing with a gun in his hand. So he is firing the bullet by rounding. So the bullet affect the persons who are in this round, right? In this area. So this is the field with the person who is here in this region. So here anybody, they will not get any effect, right? Here who are the persons are there, they will not get effect, right? Because this will be going to here. So field outside. So who are in this region, they will not get any effect, right? Inside. This is, so bullet is coming here, not like this. So inside this circle. So whoever the persons are there, for them, so no effect of this bullet, right? So similarly here also, the field inside is 0. To remember, I am telling that is. And now, so this is R less than R. So now E on surface is equal to Gm by R. Gm by R square. So the graph is like this. Means if you see outside, it is inversely proportional to E is inversely proportional to R square. E proportional to 1 by R square. At R is equal to R, the no force, no field. E is equal to 0 here, up to this. So here onwards it is exponentially decreases. This is field versus R graph for hollow sphere. So representation is very important. So now whereas potential now, potential also for these two I will explain with some concept. So now see, potential is nothing but work done. So to move the particle from infinite to one point, the work done on mass m or particle of mass m from infinity to a point in the field. Point in the field. So the work done to move one point to another point, one point to another point. In the field is called potential difference. Is called potential difference. In electric field is very, very important. Potential difference. So now see, I will give the clarity. So this is one mass M. This one have the region of field like this. So this is a field region. So here at R is equal to infinity, one point is there. So here potential is equal to 0. Now I am bringing this particle so to the point A from infinity. So here potential is VA. So then VA is equal to, potential VA is equal to E dot dr. The work done, dV, the potential difference from infinity to point A. So is work done E dot dr minus. So in integration you get this minus value. So therefore E bar is equal to negative gradient of dV by dr. Because electric field is the conservative field, people know. So the work done by them is negative. So now, so already one point is here, the A. To B I want to move. So here VA and VB. This work done is called V potential difference. So that equal to dV is equal to VA minus VB. So that equal to, so actually potential is Gm by RA minus Gm by R. So that equal to Gm of minus Gm of 1 by Ra minus 1 by Rb. And very well, work done is scalar, so potential is also scalar, we know. So that means simply we can add the potentials. In all the cases, force we find out. So there you can find out the field, means triangle, rectangle, or square. So for all those cases, you can find out potential also. The main difference there and here means there will follow the vector addition to find out the field and force in that cases or on that in that arrangements. But potential means simply will add all potentials. No, sir. So this is potential explanation. So potential due to solid sphere. So potential due to solid sphere. So we already know E values of solid sphere. And here the potential from infinity to surface and from surface to the other point inside, right? So therefore potential at a point inside point is equal to, so now gm by 2r cube 2r gm by 2r into 3 minus r square by capital R square, small r square by capital R square. So this is the distance of point inside r. Small r is distance of mass from center of the source, center of source mass. The source mass is responsible for field. So this mass I am bringing from infinite to that point. So now that is equal to here V in, this is for solid sphere. So now where R is equal to 0, that is at the center, the V at the center, potential at center is equal to, so it is minus 3 gm by 2r. So that is equal to 3 times of 3 by 2 times of the V on surface. So potential at a center means to take the particle to the center of the source mass is difficult. Means potential is nothing but work done. Their field is 0, force is 0 at the center. Means to move to the center, so the distance is decreasing, like first orbital electrons, second orbital electrons. How they are means ionization is difficult for first orbital electrons to remove, more energy required. Similarly, here also same. To take the particle from infinite to surface or near the field point is easy. From surface to inside to want to move means you have to do the against field. The work you have to do against field. So field with lesser distance of same mass will be more. So that is the reason. So whereas the potential outside, it is due to point mass of sphere or outside points, the spherical body considered as a point mass, right? That equal to minus gm by r. Small r that equal to minus gm by r plus h. So h is the distance from surface, r is radius of the earth. So for earth writing means earth is a solid sphere. So v on surface, so is equal to minus gm by r. So the graph is like this. So you can go with negative values or directly the magnitude you can consider. So here at r is equal to 0. So this is 3 by 2 of Vs, and here is Vs surface. So which is r is equal to r, and r tends to infinite. The potential becomes 0. Parabolically the graph is comes up. So here it is maximum value on surface. Sorry. So this value is not maximum. And generally the potential at infinity is equal to 0. Potential on surface is equal to minus gm by r. Potential at center is equal to minus 3 gm by 2r, 3 Vs. So here this is greater value. The potential at infinity is very big than potential at surface at big than potential at center. So compare the values are, so these magnitudes are valid like this. So magnitude only if you take means At the center, it will give the more magnitude, but it will be negative value. Right. So this is about solid sphere. So now go for hollow sphere potential. Potential for hollow sphere. So here one small concept is there. That's why I'm taking directly. I'm not writing hollow sphere. So if you take hollow sphere, the field inside is equal to E in is equal to 0 because there is no mass. Force is equal to 0. So whereas according to the potential definition, so it is minus dV by dr. E is equal to dV by dr. So whereas E is equal to 0 for inside point, I am telling. So dV is equal to 0. So that means V is constant. Potential is constant. Potential is constant. So if you understand this, therefore the V in from 0 to R. So V is equal to V in is equal to minus Gm by R. So everywhere from 0 to R surface, the potential is constant and it is decreasing with respect to R. So V out, the potential for the point outside, so that equal to minus Gm by small r or R plus H. This is small r. So now if you go with the graph is like this. So with respect to R on x-axis, the potential on y-axis. So it is constant up to R is equal to R. R is equal to R. So thereafter inversely proportional. So V inversely proportional to 1 by R and V proportional to R. And this is small r. So this is the graph for potential and so the difference is, so where E is equal to 0, V is not equal to 0. That is hollow sphere. So now here see some cases. So E is equal to 0. V is not equal to 0. So where E is not equal to 0, V is also not equal to 0. That is inside solid sphere. So this is inside hollow sphere. HALLOW or HO. Okay. So now E is not equal to 0. So V is equal to 0. And E is equal to 0. The V is equal to 0. This is at infinity. At infinity, both E and V values are 0 in that node. And but where E is not equal to 0, but potential is 0, that is on equipotential surfaces. So that we'll discuss in some other topic, right? So where E is not equal to 0, but potential is 0, that points. And this will be compared with E is equal to acceleration and potential is equal to velocity. So you'll get the cases. So this is like maximum height point. Maximum height. At that point, this is considered acceleration potential. So this is also this case also there that we'll discuss, right? So in potential case, I'll explain clear. So this is last one topic, potential energy and self energy. So one more 10 minutes, half an hour I planned, but it take 1 hour, going to be 1 hour. Sorry. So I'll make fast video. Coming into potential energy. So potential energy is work done, that equal to minus F into dr. So that equal to minus Gmm by small r, that equal to minus G into by R plus H. Potential energy. So kinetic energy, total energy, the ratio of kinetic energy, potential energy and total energy. In orbital velocity, we'll study there. That will be different topic. I'll explain. So now, so potential energy is scalar. So adding the work done. These are the formulas for potential energy U. And here, you know very clear F is equal to minus D into U by dr. So F is equal to 0 represents equilibrium, du by dr equal to 0 equilibrium. So here I forgot to tell. So potential is variable is given. So then variable in with respect to position r, that is x comma y comma z. So then E bar is equal to, we'll write dvx by dx I can plus dv by dy, not vx here, dv by dy j cap. The v has to derivate with respect to y because dv by dr, right? So similarly dv by dz into k. When the potential is variable, so then E is equal to, this is the formula, vector form. Similarly force also you can write F bar equal to fx plus fy plus fz. So in the Newton law, one point is there, that is the important notes about the Newton second law are force is vector law. That means force can be written the components of vectors. So that's why. So now, so F equal to u by dr. Force is equal to 0, that represents equilibrium. So that in core energy we studied about this more. Stable, unstable, and neutral equilibrium. So coming into self energy. Self energy nothing but the energy possessed due to possessed by a body due to constant particle. The self energy is energy possessed by a body due to particles. Particles inside. So let consider a sphere of radius r. So in this small cell we consider of radius r. So on this there is a small dm mass, dm cell with thickness dr. So your thickness is dr. So now this small element, the mass of this element is equal to m1. So that equal to m by 4 by third pi r cube into 4 by third pi r cube. So that is equal to m into r cube by r cube. This is mass of the radius r, small radius r. Then mass of the dm, small element. So that is equal to m by 4 by third pi r cube into dA, dV, that is equal to 4 pi r area into dr. 4 pi r into dr. So this 4 pi get cancelled. That is equal to 3m into, so this 4 pi r square, sorry, 4 pi r square into dr, 3m into r square by r square dr by dm by r cube. So this is m2 mass. So m2 is the mass due to this thickness. m1 is the mass of this sphere of radius r. For self energy formula, U is equal to, energy means work done, minus G into m1 m2 by small r. So this is du. So now integral du is equal to minus integral G m1 m2 by small r 0 to r integration. So now we'll substitute the values here. G into m1, capital M r cube by small r cube by capital R into m2, 3 capital M r square into dr by r cube into 1 by r. So integral minus integral 0 to r. So that is equal to, so minus, so 3 gm square, 3 gm square by r power 6, capital R power 6 comes out. So integral 0 to r. So this r and r square get cancelled. So here r power 4 dr. So that is equal to minus 3 gm square by r power 6 into r power 5 by 5 power rule is r, 0 to r. So that equal to minus 3 GMO square by 5R. This is the shelf energy of cell. Means spherical cell and a spherical shell only. So this is shelf energy due to earth, you can say spherical cell, not earth, right? So this is about potential energy and field. Thank you all. Thank you very much.